Alright, this is lesson 1.7 of our Pre-Calc 11 class. Unit 1 is called Radicals and Rational Exponents. Lesson 7 is called Operations with Radicals 3. That was a good stretch. In this lesson, we're going to talk about what is a conjugate, and related to that, we're going to talk about how to rationalize binomial denominators, which is related to conjugates, but we'll get into that. Alright, first of all, what is a conjugate? So when you have, for example, a binomial, two terms added or subtracted together, conjugates are pairs of binomials with identical terms, except one has a plus sign in the middle and one has a minus sign. So, for example, if 6 plus root 6, that's a binomial, its conjugate would be 6 minus root 6. B, negative 8 plus 2 root 3, its conjugate would be negative 8 minus 2 root 3, and so on. You can see, hopefully, the pattern here. Notice that for examples like B and D, the front number is negative, and that stays negative. That doesn't change with conjugates. It's the middle, the plus or minus in between the two terms that changes, and that's what makes those conjugates. Alright, so if I wanted to simplify an expression with radicals, and I have a denominator with a radical in it, we want to rationalize the denominator. Remember, we don't want to leave a radical in the bottom of a fraction. That's just the way we do things, standard conventions, if you will. And so, in this case though, unlike in the past, it is different. In the past, we could just multiply the top and bottom by the square root, and that would be it. However, in this case, if you, like example A, there's a square root of 2 in the bottom. If I multiply the top and the bottom by just the square root of 2, I would get rid of the radical on the root 2, but I would gain a radical 2 on 5. So it doesn't really accomplish, multiplying the top and bottom by root 2 doesn't really rationalize this one. So what we have to do is we have to multiply the top and the bottom of the fraction by the conjugate of the bottom. So the bottom is 5 plus root 2. Its conjugate is 5 minus root 2. So we're going to multiply the top by that, and we'll get 30 minus 6 root 2. We're going to multiply the bottom, and so when we multiply these conjugates, that's a binomial times a binomial. We're going to do our little box, and as you can see, there's a 5 root 2 and a negative 5 root 2. When I add those two terms together, they cancel each other out. 5 minus 5 is 0. And we're not going to write 0 root 2 in our final answer, because that's nothing. We do have 25 and negative 2, so we're going to be left with a 23 on the bottom. And as you can see, our final answer right here, we've got rid of the radical on bottom. So this counts as rationalized. We have a term of 36 and 23. 23 is a prime number, so there's no, I could pull a 6 out of the top, but I can't cancel the 6 out of the bottom. So I don't have to simplify the fraction anymore. I'm just going to leave that one as is and call it fully simplified. Example B, same thing, multiply by the conjugate at the bottom. And we're going to just multiply the top by the conjugate by 2. Multiply the conjugate by the bottom, we have our box. Middle terms cancel out, we're left with 31 on the bottom. Alright, another example, just a little bit maybe more complex, only in that the top has a binomial and not just a single term or a number. In this case, we'll do a box method to multiply the top, and we'll do box method to multiply the bottom. Notice in our answer we have two terms on top that are even numbers, and the bottom is an even number. So I can factor a 2 out from the top and the bottom. And then we could simplify our answer by doing that extra step. We should get a fully simplified answer of 18 minus 5 root 15 over negative 3. A little bit more complicated, but still quite doable. One more example here, we have another binomial over binomial. The denominator has 2 radicals. Nothing's going to change for our procedure though. We're still multiplying by the conjugate of the bottom. We're going to do a box for the top, box for the bottom, and we get our final answer No fraction simplifying to do. 8, 3, and 7 have no common factors greater than 1. So we're done. Takeaways from this, we now know what a conjugate is, and we now know that if we have a binomial denominator with a radical, in order to rationalize it, we have to multiply by the conjugate. That's it.